Okay, so this question's coming from the Calculating Periods worksheet. Specifically, we're looking at that second section, which is on calculating the period of a mass spring system. Okay, so this question says, the hummingbird makes a humming sound with its wings, which beat with a frequency of 90 hertz. Suppose that a mass is attached to a spring with a spring constant of 2.5 times 10 to the power of 2 newtons per meter. How large is this mass if its oscillation frequency is 3 times 10 to the power of negative 2 times that of the hummingbird's wings? So let's write down our variables first. So the first thing that we've been given is we've been given the frequency of the hummingbird, and then we've been told that the frequency of the mass spring system that we're looking at is the frequency of hummingbird times 3 times 10 to the power of negative 2. So we're going to take 90, we're going to multiply it by 3 times 10 to the power of 2, and if you put that into your calculator, you should get an answer of 2.7 hertz. Okay? So then we've got another number, which we're told is the spring constant. So we've got K is equal to 2.5 times 10 to the power of 2, which is 250 newtons per meter. And that's all the information that we've been given so far. Okay, so we're trying to find the mass of a system. So we're going to be using that same formula, which is T is equal to 2 pi times the square root. And this time it's the square root of mass divided by K, which is the spring constant. So we've got our spring constant. We know that we're trying to find the mass of the system. The only problem is initially we don't have the period. Okay, so we know we're going to need to find that and then rearrange this formula to solve for m instead of for t. Okay, so I'm going to do that first just so we know what formula we're going to be working with. So we're going to take t, we're going to divide it by 2 pi. Okay, then we're going to square both sides. So we end up with t divided by 2 pi squared. And then in this particular formula, we're going to multiply both sides by k, which gives us k times t divided by 2 pi squared is equal to mass. So once we have t, we should be able to use our spring constant in order to find m. Now we haven't been given t, which is our period in the question, but you can always find period as long as you've been given frequency, because the two are inversely related. So if you look on your formula sheet, there's a formula that says that t is always equal to 1 divided by the frequency. And the reason that we have this relationship is because essentially what t is the amount of time that it takes the mass in the spring mass system to complete one full cycle. So it goes out to the equilibrium point, which is approximately, I don't know what happened there. All right, we're going to keep going. So it goes out to the equilibrium point, then reaches its full displacement at the end here, then goes back past the equilibrium point and back to its state of total compression here. So again, the period is the amount of time that it takes to do that one whole cycle. The frequency is how long does it get in a given amount of time. So let's say how far does it go during 1 second, right? If you have a longer period, so if it takes longer to complete that full cycle, then it's not going to go as far in 1 second because obviously it's going slower. So the larger your t is, or your period is, the smaller your frequency is going to be, because you won't be able to go as far per second if it takes you longer to complete 1 cycle. I'm not really sure what's happened to my question here, so I'm just going to write all of that information again. So we've got K is equal to 250 newtons per meter, F is equal to 2.7 hertz, okay, and then we're going to use our formula T is equal to 1 divided by F in order to find our period. Okay, and then we're going to use the formula that we derived earlier, which is K times T divided by 2 pi squared in order to find our mass. Okay, so I'm going to go ahead and bring my scientific calculator up. Okay, the first thing that I'm going to do is I'm going to go 1 divided by 2.7 in order to give me my period. So your period, as you can see on the answer key, should have been 0.370 repeating. Okay, then I'm going to take this number, which is now my t value. I'm going to divide it by 2 pi in brackets. Okay, I'm going to square that number, and then I'm going to multiply it by k, which is 250, to give me the mass, which should have been 0.868665, blah, 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 kilograms.